Hello everyone, this is Mr. Khan from Pakistan from RealXenomania Telegram group. Today's lecture is third lecture about reversing, and as promised that I will continue this series in my free time. Whenever I get free time, I will record videos for you. So today we are going to talk about how to find the emulator detection offset. Why is the case 10 related to emulator detection, and why people talk about case 10 all the time when they want to bypass emulator to mobile lobby. This lecture will cover all these confusions and how to find it, how to reverse it from strings, how to find the correct case for patching. Also, you can apply this method for any game that is using LibAnogs library. So currently Call of Duty Mobile, PUBG Lite, and I think Apex Legends also use the LibAnogs library. You can use this method to find the correct emulator detection offsets, plural. Because there is not one single offset that you can use for correctly bypassing emulator detection, and you will learn in this video that only bypassing with case 10 gives you ban, because the detection is happening in other functions also. So let's go ahead, open your target library, whichever library of the game you are targeting. I have here for PUBG Mobile 2.1 version a LibAnogs library. I have loaded it completely and the library is ready here. You can see it here, ready. If you see yellow icon here, it means you should give the IDA auto analysis method some time. Probably on good PC you would see 10 to 15 minutes, and a very good PC you would see it completely analyzed in 2-3 minutes, but in slow PCs, Core i5 and lower versions, older PCs, you will see it analyzing it in 35 to 40 minutes. It is a small library, 3 to 4 MB maximum in size. When the library is completely analyzed, go to strings window here. This is a strings subview. If you don't see it, you can open it from a subview menu option here, or by clicking the shift plus F12. Okay, you will see it here, and go here. Pretty straightforward process here. Just search for emulator, or if you have the names window open here, similarly you can open it from subview, just like strings here, names or functions. So the names window is open. You can control F inside to open this dialog box, the input box, and then you can search for emulator. Okay, so you will see two things here. One is the emulator name pointer, which is a DCD variable, okay, DCB variable, B for byte. And the other thing you will see here is a string value. A string is denoted by A in IDA, and also you will see that in the name there is a small a prefixed to the string. Okay, prefixed means before the actual name, something attached to a name before it is started is called a prefix. So this is a small a prefix to this. You can double click here and reach the string, or you can double click here. So you can see that both these windows have the same address, 3591 DC. Okay, so I'll use the strings route here to go back in reverse and try to track which functions are using this string. So obviously when imagine when the game starts and the emulator is detected, that it is game loop or LD player or smart gaga or BlueStacks or something else, or Nox player, for example, people are playing with that also. When the function which uses the detection of emulator is reached, it calls this string. and this string is basically this standing bar thing. I don't know what it is called in English, but it is like the OR. We use it for the OR operation, logical OR inside programming. And this is the emulator name string equals, and then there will be some other thing inside the same function which will cover this place here after the equal sign. So let's go and see which functions are using this string. We can reverse the references with control plus X, okay, and we can also do it with right click and xref graph 2. But the listing is from control plus X, or if you prefer the graphical view, you can xref the graphs here, and you will see that these functions are calling it. The first one is the DCD location, which is not a function, but it is there for it is like a global variable kind of thing, and a pointer is saved inside there. Obviously it is called in the NOSDK IOCTL underscore 0. Remember that this is not the same function which we use for patching case 10. This is not NOSDK IOCTL old underscore 0. This is the NOSDK IOCTL underscore 0. And why is it calling it? Because it is being called by these functions 35ODC, 352BO, 28A, 9BO. okay, these three functions are responsible for telling this NOSDK IOCTL underscore 0 to find and detect emulator and use this string. So this is a major function here. You cannot possibly patch it directly. You can patch these three functions here to make sure that you are stopping the emulator detection completely. Okay, now also you can use some other creativity. If you don't want to patch these two functions, you can go up the branch and patch these three functions instead of patching this one function. But on this branch there is no parent here. You can only patch this function to stop the call to this when it is using emulator detection. And we will see a little bit later why how is this function detecting emulator inside. We will reverse this function itself and see what is being done before using this string. And also you can see that the 352B0 is calling this function to detect emulator. We can reverse patch instead of these two functions. And some people you would have heard from that there is a powerful method of patching DCD variables. So this is a DCD variable sub 103478. If you patch this sub, it will not be able to call this function, so this path will get disabled, but this path will still be enabled, and this will effectively call this function to check emulator and then return the emulator name string. Okay, so it is all about creativity, where you want to patch, what you want to patch, how you want to patch, because there is not a single method of patching. Most people are using the return based patches 0000A0 E3 1EFF2 FE1 or 0100A0 E3 1EFF2 FE1, or some people are using mixed mode like patching single byte inside, mid function patching, reverse patching, forward patching, function disabling, DCD disabling, single byte patching. There are multiple methods how you can patch a certain path. This is a path here to achieve something that you want. For example, I want to disable the emulator detection. So if is it possible that I can patch this function NOSDK IOCTL underscore 0? So this we will talk about it a little while later. Okay, first let us go and see NOSDK IOCTL underscore 0, what this function is. We can list our references here and double click it, and then when we reach our target function, which is calling the emulator detection, this function, we can click inside it and click F5 to get to this pseudocode view. This is a pseudocode view, and here we see that the emulator name equals this string is being used and passed to this function. But before using this function, we have to know logically that the emulator detection has already been completed and the emulator name has already been taken from somewhere in memory, and now the emulator name equals here should be something that is being written here and then passed to this function 262d7a. So it means that just before this function is called, there should be a function, this one or this one, which is responsible for detection of the emulator. Okay, so the first thing is let us go up in this same case, in this same label. There is no special function except the C function, the native function AEABI memory clear 8, which is a copy of memclear function from native C library function on Android, and then this is the malloc function, which is a popular function in C++. If you are good programmers, you know about it. And there are some dereferencing and changing of values on a certain variables referenced by these variables v5, and we can see up that the v5 is r0, which is the first parameter passed to the function, which is a1. Okay, r0 is always the first parameter of a function call. So disregarding all that, let's go forward and see that here are a few functions, this function, this function. Okay, these are being run and this is also being run, but in this case, which is case 18 for this NOSTK IOCTL_0, case 18, when this case is jumped from the switch on the first parameter passed to this NOSTK IOCTL A1, which is also on R0, and when the switch reaches the 18th case, it calls only the first function here, NOSTK IOCTL old_0 on case 18. Okay, and when this case 18 is run, some functions run also here. So similarly, we can see that when this case is ended, some return is done from this function. This is the same scenario for all cases. In all switch statements, a case is called. So if you see that this is the case 10, this is not the same case 10 of NOSTK IOCTL old_0. This is actually a different case for the NOSTK IOCTL_0, not the one which we are targeting right now. So this is a different case 10, but when this case 10 is called, some native library functions are run, some dereferencing and changing of values on the register 0 is done, or possibly on the stake also. If v6 is on the stake, we will have to verify it. For example, these are stake variables. These are not from the local variable. These are the stake variables. You see that this is the stake of NOSTK IOCTL_0, and there are a lot of variables being used inside in the same stake. So yes, those variables like v24, v21, these are on the stake. Okay, and later on in this case 10, the first function which is inside this library libsafe or libanox is the NOSTK IOCTL old_0, and the first parameter passed, which is the case number, it is the 10, the 10th case that is passed to this. So it means that after this case 10 is run inside this function, a certain result is taken. Okay, result of NO, let us call it NO, result of NO, This result of NO is then checked. If this result is 1, then the emulator is detected and the emulator name should be here. When the name of emulator is detected by this function, this sub 263574 is responsible for the name detection. This is just a guess. This is like a beginner level stuff that I'm trying to tell you. It could be another function also, but I'm trying to tell you about the mindset of a beginner reverser, how they would think and how to think critically and logically and find correct results in correct pages and correct functions if you want to achieve something. So it is obvious that when this function is run, a result is saved here in this variable, and then that result is checked. If it is 1, then the emulator is already detected and the emulator name should be here after the equal sign. Okay, so where is this emulator name being detected? This is the first function, this is the result, and then the result is checked. It means between these two lines some other function is running which is finding the emulator name, and here it is the only function that is being run which should be finding the emulator name, by the way. Or this could be a relay function, this could be running multiple functions inside itself. Okay, you can check it later on. So here we know now that the NOSDK IOCTL old underscore 0, when case 10 is passed to it, this is the first parameter, and the first parameter is always R0, and on R0 the switch statements are applied which we call the jump table, and based on those switch statements certain functions run. So this first parameter is the case number for this NOSDK IOCTL old underscore 0 function. When this is run with case 10, a certain return value is saved, and that return value is checked. If it is equal to 1, then the emulator is already detected. If it is equal to 0, then it means emulator is not detected. So now there are multiple ways. Now you know that the case 10 is here, and we found it by reversing from emulator name. Okay, we found it by reversing from emulator name. We found it, sorry for my rooster, he crows all day. Okay, so we found it from the emulator name by reversing it and reaching the functions responsible for using this string, and then we got here and we decompiled it, and we found out that the function NOSDK IOCTL underscore 0, it is in fact passing case 10 to the NOSDK IOCTL old underscore 0, which is responsible for detection of the emulator. It is now completely obvious. Now we know that case 10 is called from here, and NOSDK IOCTL old underscore 0 is our target function. So we can double click it and reach it. We can find the case 10 here. This is the case 10, and inside case 10 these two functions are responsible for detection of emulator. So now we have multiple methods of patching it. Okay, we can like patch it. We can patch it in multiple ways, like changing the case number 10 to something else. Okay, this is the first method. So you saw that here if we change this to something else, and this is the same method used in some public bypasses also. So people are actually using their brains now. This is good to see. And also you can go inside here, and as we know now that the case 10 is calling two functions, 41F10, 43206. So you can remove these two functions from existence. So if we go to 41F10, let's say for example 41F10, and you can see the hierarchy of calls. The first call is done from case 10 of the NOSTK IOCTL old underscore 0, but there are multiple calls from other locations also. So not only this function, the NOSTK IOCTL old underscore 0 is checking and using this function, there are multiple functions that could be responsible for detection of emulators. So this is why when you patch only case 10 in any game, let's say in PUBG you patch only case 10 and you start a game and you play 1 or 2 games and then you log out, and then when you log in again with same case 10 patched, you see 2 months ban. Why? Because you did not care about the remaining functions here. All of these functions are necessary, okay, because they are calling the function which is checking emulator for us. Not only case 10 is checking, all of these functions are checking emulator using this function sub41F10. They are calling this function directly. Look, branch with link, branch with link, branch with link. BL means branch with link. So they are jumping here to this function and running it. Okay, another thing you have to see in the pseudocode now is there is another function 43206, and it is dependent on the result returned by this function. When this function is run, a certain result is generated, and that result is passed as on register 0 of the processor to this function as the first argument, and when this is completed, whatever value this function returns, it is returned to the caller function. So let's see this function now. This is the first parameter. It is saved in v6, and v6 is used here in the 43192 location in this sub, and then the result is saved in v17. If the result is 0, then this function is called. If the result is non-zero, then nothing is done. If the result is 0, this function is called and used. Okay, just a second. So this is how you find the logic behind things that are happening inside any library. So we were taking notes. So the first thing is 41F10. We can do like patch all its callers. Okay, this is one method. Another method is like this: patch this function inside so that it returns a certain value all the time. So if we go here, so it is checking this dword location, which is a 4-byte value here. You see it from C to 0. This is a 4-byte value, and this location will be filled up when the game is run. So this location is empty now. This is unknown, but we only know that it is a 4-byte location. So when that dword is checked, if this location which is saved in result, if this is 0, if this is completely 0, then all of these things will run. Whatever is the result in this, it will return. So obviously if this is 0, then all of this will run, and the result is not the result is being changed here. 3D4A6C, this is changed. It is double checked. If it is still 0, then the result is changed here in this location. In this function, if you see, the result is changed in this location, and then if you go here, location 30BA54, and here the result is going to be v1 equal to 1, and then result v2. If not v2, this is a 0 passed to this function. Okay, this is a thread now. It is calling itself again and again. So the result is going to be 0. Okay, so 0 back to here, 0 back to here, and from here back again. Okay, 0 is here now. Okay, so if this is non-zero, then all of these are run, otherwise nothing is being done. So this is a simple function sub4 when f10. It checks this location. If this is non-zero, then nothing is done here. Okay, if this is 0, then all of these things are run. So what we can do here is change this function. We can patch it with a simple function like this. We can patch it with a simple function like this, 0 0 2 0 7 0 4 7. This will disable all this function now, and when this function is run here in this location, sorry, I always lose track of what I am doing in IDE. Okay, here, so when this is run, nothing will happen. Okay, nothing will happen, and no stake variable values or no global variables or no DCD variables or DCB variables will be changed. So this is a certain thing that is necessary for bypassing the emulator. When this is not run, obviously the variables that were being checked, like this 3D4A6C, this will stay intact. Whatever this value is, we are not touching it. Okay, and after that this function is run. When this function is run, it is checking the second parameter a2. If it is not equal to 10, then return -1. So here we can see in the original function, this is equal to 10 because we are in case 10. So case 10 is passed to here 10. We want to tell the game that here case 10 is not being passed. So we can change the value of case 10 here. We can change it here by returning -1, simply by returning -1 here. Or let's see what if it is 10. In fact it is 10. A2 is now 10. So on A2, if it is not 10, then return -1. It could be a symbol of abnormal termination, or it could be a symbol for or a signal for abnormal working. We don't know it yet. So what we do, we will study this function now. So let's see if v8 is equal to a3. A3 is the third argument, and the third argument in here is v5, which is go up. So v5 is a dereference of r9 on register 9. It could be from the previous function. What I mean is this. Let me show you. When we reach here and we reach here again, NUSTK IOCTL old underscore 0, and then we reach here some function calling this NUSTK IOCTL old, like this 34254. This is calling, but you see when this function is called, a few lines before this function is called, the register number 5 is being changed, and the it is changed with a register 0 value. So R0 is saved to R5, and then this R5 is not changed. You see, this is not changed, and then NUSTK IOCTL old underscore 0 is called. When this is called, you come here in the disassembly view in the pseudocode, The R5 is the fifth argument, 1 2 3 4 5. So this is the fifth argument, A5. Okay, and R9 is register number 9. So if we see here, R9 is also modified by moving value from R1 into R9. So the R9 is here, sorry, in the previous, before calling it. So here we don't see R9, but R9 could be from anywhere before this function. Let's see if this function is called from some other location. So R9 could be here. R9 could be from other functions which has modified the value of register 9. So that value is there. We have to believe it that when this function is running, the register 9 has some value. Based on that value, when we see the pseudocode, the v5 is a character value which is taken from R9. Okay, and that R9 is being used below in this function. Okay, when you reach case 10 and when you call 43206, and here R9 is v7 now, and then v7 is being used below. Okay, similarly v8 is also used, and similarly all these variables are already present in memory. v7 is already used, which is now R9, by passing its value to 43192. So okay, back to the main topic which we were discussing. When we call this NOSDK IOCTL old_0, and when the case 10 is called, case 10 uses these two functions. For the first function, we now know how to patch it. When we do this, this function will be patched. But what about the second function? With the second function, when it is called, it checks for A2. If it is not equal to 10, then return -1. So what we can do here is two things. For 43206, we can simply return -1 from it, like this. Okay, but there could be other methods too which are better. So for that better method, we are studying this function below this return -1. Okay, so we are trying to understand what is happening beneath these lines, so we can know what to do in a smart way. So you see now the v8, it is taking value from E3, and based on this v8, a certain body is being executed. After this execution is done, there are some logical implementations. v9 is not equal to 0, true or false. So v16 will take 1 or 0. Okay, when it is 1 or 0, this is passed to this function, and after that a lot of other checks, logical checks. If v7 is 0, if v8 is 0, okay, all of these things are done, and after completing all of this, result is returned. So you see, in most cases the result is 1, except here when they are returning with -1. When they return with 1, it means that all of these things are okay and all of these things are completed. Return 0 will be when v18 is not equal to 0, and v18 is from v17, which is calculated here. So this simply means that if this function is not run, then return 0. So by returning 0 to this function, what you are telling the game is something is wrong and this function is not executed. So return 0 here is a bad patch. Okay, now what about return -1? We already saw that return -1 is a good patch, but it could also tell the game that there is abnormal function execution. This function is not run, and now -1 is being returned to it. So what we can do now, we have to check for the last value, return equal to 1. Return 1 if this is a good patch, or if -1 is a good patch. We have to analyze it. Okay, this is what I am trying to tell you. Let's see where -1 is being returned. -1 is the result, and result is being calculated in two places precisely, but it is also from R0, the first parameter passed to 43206. Let's see when the 43206 is called. Let's find case 10 here. Okay, this is case 10, and R0 is not present here, but R0 is the first parameter passed, so it is always equal to 10, and now it is also copied on R1. Okay, so 41F10 is called directly, and we can patch this here also. So for 41F10 we can patch it here or directly by using this. If you want to patch the function directly, you can patch it here, 34684, like this. First find out how many distance we have from A to 8. We have from 8 to 4 we have 4 bytes of location present, so we can write a 4 byte NOP like this. If there are 2 bytes, then you can use 00BF, okay, like this, but this one is enough. This is 4 bytes, so it is a good patch here. So this sub 41F10 call will be removed, so this is called removing call, okay, and this is called removing the function from memory. All right, removing the function from memory. Okay, these are the two methods, and we also know that we have to patch all its callers, so there are about 9-8 callers. We have to patch them. Okay, this is your homework. Now 43206, we know that we can return -1 here. This is the return -1. Okay, and then there could be other methods also. So for other methods we are checking here. See here 43206 is being called. We can patch it like this, directly like this, you know, 34692, and sorry, I am laying down so I don't see the keyboard. Okay, you can do it like this, 00207047. Why did I write a 4 byte NOP instead of 2 byte NOP? Because we have 6 minus 2 equals 4, so this instruction is taking up 4 byte place. We can also confirm it by clicking here. This click is necessary, then go to hex weave, and you will see that this instruction is occupying 4 byte place. Similarly, if you see the next instruction, this is taking up 2 byte place. Okay, this instruction is taking up how much? 4 byte place. So for 4 byte we need 4 byte patching. This is a 4 byte NOP. So what we did was removed the call. So now by using this direct with this direct, what you are doing is you are essentially removing case 10 from memory. Okay, so how you can bypass PUBG now? So method 1 is removing calls, removing case 10 calls. So what we learn now is use this one and this one. This is first method. What about method 2 now? Another method we can do is patch functions. Patch function or functions being called. So for that purpose what we did was this 41F10 with this patch. Okay, this is the first function which case 10 is calling here, 41F10. The second one is 43206. We don't know if this is a good function or a bad function, but we know that only case 10 is calling it. Only case 10 is calling it. And what was this function about? It was, if you go back, 43206, these two functions are dependent on each other. The result returned by one function is used in another function. So we can simply disable this function because it is only used in case 10, nowhere else used. So we can disable this function completely by patching the function be called and disabling them. So we are disabling the functions now. How are we disabling this? By doing this: patch this function with 0020747. This 0020747 disables the function completely. Okay, this you have to remember. And also this function 43206 by the same method. Okay, so only these two patches are enough for disabling the complete case 10. You can also argue with me that this one is not necessary, and by patching only this one it is enough. But we have seen in pseudocode and also in IDE view that these two functions are dependent on each other and these two must be patched. Okay, now we were going back to our case detection. We found it by using this, getting to the reference here, decompiling it. We saw that the first problem here was the passing of case 10, and we completed that first step with these functions. So if you are doing method 1, these two offsets is disabling this case 10 here. Okay, this is disabling this. Or if you want to follow method 2, in this method we are disabling case 10 from NOSDKICTL old underscore 0. Okay, but this is the first thing that we patched. Now what about the other functions, these functions? What about these functions? Because when this is run completely, the result comes here. If result is equal to 1, then emulator is detected, otherwise nothing happens. So what we can do here is, we now know, we were puzzled by this question, if by returning -1 is good for us or by returning 1 is better for us. And I already gave you answer here that the return -1 is better from that function. So if we are patching 43206 in a smart way, returning -1 only here will disable everything completely here. So this disabling this function 43206 with 207047 is not a good idea if you are using the method 2. Instead we will adopt it like this. Okay, so this will complete your patch. For this thing, the 34684 and 34692, if you are removing the call to the function, then nothing will be returned here, and when nothing is returned here, these blocks will become problematic for you. So this method 34692, we cannot remove the call. You understand now? Go back to here. When the NOSDKICTL old underscore 0 is called, sorry, when this is called, you see I lose track all the time here. Okay, so this is the target function which we were studying, and you go to case 10 here. This location needs to be run and it needs to return something into R0. So how you can use it with method 1? By removing the case 10 call. Instead of disabling it with NOP, you can move a certain value into R0 and then it will do its thing automatically. So we saw that if we return -1 to R0, everything is fine. So here, instead of doing this, we can do this. Okay, this will not remove the call, it will change R0 value, which is necessary for bypassing. Okay, so these two offsets are now necessary and safe for bypassing emulator, and similarly a combination of these two offsets is okay. And now we also studied that the third method was to patch all callers of 41F10 to find out if we are missing something or not. Let's go with method number 3 by removing all calls to 41F10. How can we do that? Go to 41F10. By the way, 41F10 is this function which is inside case 10, and we saw that this function is called from multiple locations, which can become problematic later on in our game. So if we are patching it with 00207047, this is okay for all calls. Okay, so this is a complete method, and this is also okay for all callers. Okay, but a more professional or better way would be to patch all the calls to this function. Instead of disabling this function completely, we can disable all the calls by finding them first. So these are our calls. We can copy all here, and we can take it to our notepad. Okay, and we can remove these two lines. Then we can also remove these things which we don't need. This one. So we are now left with these functions, and we can remove the plus plus from here. If you are using notepad plus plus, you can use this with regex formulas. Regex formulas will give you ease of mind, and it will make your work fast. So okay, now we know that all these functions are calling this function 41F10. We can disable all those calls. So by disabling all those calls mean, if you go to this location, find where it is called, then disable that location by 00207047. Okay, and actually I made a small mistake here, a stupid mistake. Go here, copy all. Oh, okay, we will do it manually. Just go to the second one here. This is location 4462C. Okay, copy it, bring it here. Again, escape, Control X, go here, copy this offset, bring it here, Control Escape, Control X, 44678, 4F678, copy it here, escape, Control X, go to next location, find the location of the call, paste it, escape, Control X. Okay, do this method multiple times to capture all the exact instructions that is calling 41F10. Okay, you will see you will have a small list of instructions that are checking this function again and again in memory. Again, remember that there are multiple creative methods to do everything here. You can also do a single byte patching that will disable the emulator detection completely, but it's all up to you guys to use your minds and see what better methods can be implemented in your side of the page that can get you the same purpose, the same target which you are after. Alright, so we have now our offsets which are calling what 41F10. Why are we trying to patch this? Because this is the function that is called inside case 10 and it could be critical. We are trying to disable all references to this function, and by that I mean if we see the graph of this function, so in this graph you see that 4F668, okay, the first one, actually it is a plus instruction offset, but this is the sub 1FB2, so 1FB5, okay, because you know 7E31C, 7E4, and there are others also, so there are some arrows going to that side like 10C. No, I could be wrong here, so it could be like or I'll do another thing. There is a good feature here, proximity weave. You can find it like this, and you can see all the functions that are calling this function in graphical format. So this is 44628, we already know about it, and similarly you can see all the functions here. So we already know that how many functions are calling it, and we got all the locations of those functions, and each of these instructions we have to patch with this. Okay, this is a rough draft that I'm making now, and now I will verify each function. Now go to each function address, see the difference between this next and the previous offset. This is 4 bytes, so this is okay. Go to the next one, this is E and 2. How many EF01, EF01, so this is 4 byte, okay. Go again to the next one, 8 and C is 4. Go to the next one, this is E and 2 is 4. Go to the next one, this is C and 0 is 4 byte distance. Go 04 is 4 byte distance, okay. Go to the next one, 6 and A is 4 byte distance, actually 6 byte distance, but because 6 is 7, 6, 7, 8, 9A, this is about 5 bytes, but that's fine. Go to the next one, this is 6 and A, this is also 4 or 5 bytes. 4 and 8 is 4 bytes. I think 6 and A is 4 bytes. 0 and 4 is 4 bytes, and E and 2 is 4 bytes. So let's see, I was confused here in the 6 and A. Let's click and go to hex view. This is 4 bytes, so I was wrong, it is not 5, it is 4 bytes. Alright, so now we know all the offsets that are needed to disable this function only, and with these, because I'm disables call to 41F10, okay. So this is for all of these offsets. But what about this one? This one needs to be added in method 3, so you can add this one, okay. Because you have disabled all these, so you will have to add this one, and because this one has only one parent or one caller, so we don't need to go in detail about this. So it should be added by itself, and all of these. So this is safe way to bypass emulator, to avoid detection, to avoid 2 months ban. And this method you can apply on any game, as I talked in the start of this video. Any game using LabAnogs library. Alright, so these are 3 methods now, and there is another method also which I'm keeping in for private video. The private video will be sold in the next season, and that is called method 4 is single byte patching. Okay, and there is another method 5 also, which is the color diversion technique. So all these methods, you can also use another method called mid function patching. You can Google it and you will find what I mean. Okay, mid function patching. So that's it for today's video. I hope you guys have learned a little bit from this video. So by using any of these 3 methods, you can design your own bypass, which will be safe without any 2 months ban on PUBG, and which will be safe on any kind of bans on any kind of game in the market. Okay, this is a guarantee if you do it completely like this, exactly like this, by disabling the calls to the functions that are being used in case 10, if case 10 is your emulator detection case. Okay, and we have so far reversed only this single function, so you can follow this function also. Okay, go back here, see that here it is found that you are running etc etc something. So when this function is called, it is running and there is an warning in front of it, and then a certain condition is checked. Based on that condition, something else is done. Okay, it means that when this function is called 42E90, emulator is already being detected. 42E90. When this is called, are there any callers? Yes, 42E88. Are there any callers to this? No. So only 42E90 has only one caller. If we go to the graph, it will show us only one caller. So 42E88, and it is found that you are running in Android emulator. It is directly calling 42E90. Okay, so we can patch it just to be safe, 42E88. This is just a precautionary measure. Precautionary measure. You can patch it with your above patches like this. Okay, this you can add it to your patches, your methods that you have made. Alright, I think you understood me. Just like that, just for the sake of being precautious. This is the correct and professional way to bypass emulator, not like idiots who post on UC patch case 10, and if you get 2 month ban, patch more, patch case 23, go to case 34, go to case 37. No. Make patches professionally, then you don't need any other things. Make patches professionally. Okay, no need for patching more. Have you tried to ask people on UC or on other platforms or on Telegram or Discord, when they tell you patch more, have you tried to ask them what the hell do you mean by patch more? What the fuck is this answer? This is not a proper answer. Answer me professionally. Tell them. Whoever tell you to patch more, that is not a professional answer. Patch more is nothing. It doesn't mean anything. It means that the person who is telling you to patch more, he doesn't know itself what it means. He doesn't know the solution, so he is trying to be smart and to look smart in front of you and to tell you that I know more, but I'm not telling you. What the hell, bro? Tell me, or just confess that you don't know the answer. What the fuck is this? Patch more. Okay, so those people are idiots. Don't follow them. Use your brains. Study the books that I have provided on this channel 8 months ago. If any of you guys have studied only one book out of those 3-4 books that I have provided, now you would understand completely what I am saying here, and you would be able to absorb this knowledge very easily in minutes and use it in your own settings for any of your program that you are patching. This file I am going to provide in the group now too. Okay, good luck for your adventures. Keep learning. The only proper way to learn is to read from books. Don't beg people to tell you. Don't beg people to make videos for you. Nobody in the whole world or the whole universe can do that for you guys. Go study books, learn, come back, try to absorb as much information on internet as possible, from guided hacking, from unknown cheats, from YouTube, from people like me, from people like others who are trying to educate people. And also think critically. If I am telling you to patch these things, you must think first that maybe Mr. Khan is wrong, maybe he is a noob, maybe he doesn't know and he is trying to make this video just for show off. No, you have to think critically just like that. And if after critically thinking you see that my patches are okay, my offsets are 100% correct, my methods are correct, nobody else has explained it to you like I am explaining to you now, then you should accept what I say to you next. And what I am saying to you next is this: if you want to become good reversers, learn from books. Books only, bros. Books. If you study book, just give it 15-20 days, you will cover more than the best reversers in the market. You will cover more than the best reversers in the market. Trust me on this thing. If you study one book for 20-25 days, believe me, you will be among the less than 1% people who understands things exactly. And then you could be making patches that I would not have thought about previously. And you would come to my inbox and tell me, Khan bro, look, I patch with this and this happens. And I will tell you, oh good, this is a new method, I didn't know about it, thank you for sharing. So this is how we all learned, and we are learning daily new methods, new things we are discovering. We are reading internet, we are giving it 1-2 hours daily. Learning is a journey. It doesn't end. It is a never ending journey. Okay, learn, keep learning, keep absorbing knowledge and keep applying it. Play with it, have fun with it. Okay, that's it for today's video. Goodbye, and see you with the next video some other time, inshallah. Fi amanillah. Allah Hafiz.